says that the enthalpy change for the reaction represented above, A turns into X. So essentially going right along this pathway here. It's delta HT. It says the reaction can be broken down into a series of steps where A makes B, then B makes C, and then C makes X. It says a relationship that must exist is what? And the simplest and easiest relationship to see is that delta HT equals delta H1 plus H2 plus H3. All right. So if that's true, let's look at answer choice A. It says delta HT minus H1 minus H2 minus H3 equals 0. Well, that looks like it would have to be true. If you add all of them together twice, it equals 0. No, that's not going to work. H3 minus H1 plus H2 equals H. No. None of these other ones make any sense. So the answer is A. It's the first option, and it's the correct one. So now let's look at this next one. I'm not going to show you the choices yet. Take a minute and see if you can figure out this one. We've got two equations with delta H's, and we're trying to figure out delta H for this reaction. All right, so in order to do this, you need solid iodine as a reactant, which we have right there. You need iodine gas as a product, which we have right there. So this reaction needs to be reversed. So if you reverse a reaction, you change delta H as positive 5 kilojoules per mole. And then we need to double everything. So this would become 52, and this would become 10. And you add them together, and you get 62 kilojoules per mole. And it's positive 62. Now, this should make sense because sublimation going from a solid to a gas has to be endothermic. If you got a delta H that's negative, that would be a problem. So here we have down here 62. Now let's look at one more example. All right, so in this reaction, in this problem, the only thing that's relevant, we're going to be looking at the question stem up here, and then we're going to look at part F. So it says, for the vaporization of solid iodine, the value of delta H is 62 kilojoules per mole, which is great. That's what we found in the previous problem. They're consistent from year to year. This is real information. Using that information, plus, of course, the information above, calculate the value of delta H for this reaction, where it says I2 gas plus Cl2 gas makes 2 ICLs. I don't see any ICLs here. But what I do see up here is an ICL. And its delta H is 18 kilojoules per mole. Right? So take a minute and see if you can figure out what the answer to this is. All right. Now, since the overall equation we're looking at has 2 ICLs, we need to go up here and double this reaction. So delta H for that reaction is going to be, when we double it, is going to be 36 kilojoules per mole. And then we need to have, instead of solid iodine, we need iodine gas. So we need to cancel out the solid iodine when we add these equations together. So we need to take this reaction and reverse it. And so that would change the sign to negative 62. So 36 plus negative 62. And then we see what that equals. That would be negative 26 kilojoules per mole. Right. Now, if you're a little uncertain about this, if we took that first equation and we doubled it, it gives us I2 plus Cl2, I2 gas plus Cl2 gas makes 2ICl gases. And when we doubled that, that was 36 kilojoules. And then we're going to take I2 as a solid makes I2 as a gas, and that's negative 62. And if we were to add all of this together, our I2 gases cancel out, leaving us with I2 solid plus Cl2 gas makes 2I. Let me rewrite that. It got really messy all of a sudden. 2ICl gases. So hopefully that makes a little bit of sense for you. I've got a few problems for you to take a look at and see what you can do with them. All right, so let's take a look at this problem. It has the reaction of ethylene, and it tells you that delta H is negative 1323, and it wants to know what the value of delta H is if it produced liquid water rather than water vapor. So take a second and see if you can answer this question. All right, hopefully you got that the correct answer is E. Because if you look at this reaction, if we're going to replace water vapor with liquid water, we need to add to that equation this reaction times 2. And so we would need to add to that negative 44 times 2. So you're taking negative 1,323 kilojoules plus negative 88 kilojoules. And that gives you negative 1411 kilojoules. All right, let's take a look at this next problem. So this one is giving us bond energies, and it's asking us to find delta H for a reaction. So take a minute and see if you can figure out what delta H for the reaction would be. All right, with any luck, you managed to come up with the correct answer being B. If you did not get B for the correct answer, let's look at this. For this, delta H equals bonds broken minus bonds formed. Well, the bonds we have to break are an iodine-iodine bond, so that's 150. Plus, we have to break 3 chlorine-chlorine bonds, which is 3 times 240. And then we have to form iodine chloride bonds. Now, in each ICl3 are 3 iodine chloride bonds, and we're making 2 of them, so we're making 6 of them. Now, the real trick is to see if you could do this without a calculator. So we have 150 plus 720 minus 6 times 210. That's going to be 1,260. So we've got, this is where the math can get a little bit tricky, but ultimately that's like 870 minus 1260. And at this point, you don't have to actually be able to do all of the math because you know this is going to be a negative number, but it's not going to be negative 870. So the only other reasonable choice is answer choice B. Now, this is the trick because on multiple choice questions on the AP exam, you cannot use a calculator. So you need to be able to do these problems without one.